Hello everyone, let's look at Lab 11. With Lab 11 and Lab 12, we start to work on a different trainer, different type of trainer. It's called process control trainer. And with this type of control, we will start to see a different type of diagram. Down here you see P and ID. Notably, uh, you may heard a very common, very popular term called PID, right? Which is also very big subject, big topic in process control. But it's totally different from what we see in this lab. This is P and ID, stands for piping and instrumentation diagram, right? So we can understand this simple diagram with all the equipment devices included in this picture, right? So first on here you can see on this unit we have a water tank, and with the water tank it will supply the water going to the pump. With the pump you have a speed control, SC1, and with the pump, you can see that's the picture from that trainer, right? It has a water tank on here, and the motor drive the pump underneath over here, right? So with the pump pouring the water out, and then you can see here it will go into a sort of a reservoir, right? So actually on here on the screen you see here, this is the reservoir on here. So water go in. You will see that video in a moment. All right. So you can see here there's a pipe going here. So actually that's the pipe going to the bottom here, right? You can see that's the water level on here right now, right? So water can also come out from the reservoir and go back to the tank. So it's a loop, it's a circle, right? So by controlling different valve and also the speed of the pump, we can actually have the water level on different part of the reservoir. Then how do we control the pump? You can see here the speed control is it's connected by a LIC. So in the moment you'll see those detailed pictures on the devices. So in this lab, the LIC actually is just a term in the PNID. L level, I indicator, level indicator controller, right? So we use a device to control the motor, in turn to control the pump. Then the water will go into the reservoir on different speed, so we can have a different level of the water. So in fact, if you look at the title of this lab, it's called pressure measurement for level. All right, so I can expand from here. So with the what I just mentioned, with the speed control of the pump, or we can also do the valve control with the water in and out. So the water inside the reservoir can be adjusted. So the purpose of this lab is we want to measure the water level. So as you can see on the reservoir on the outside, we have a ruler here. We have a measurement, right? So you can visually check how high is the water. Like right now it's roughly on 4 inches on here, right? So but this is a visual check, right? So you have to have the operator look at it. Then how do we control the water level with electrical circuit and devices? We have to use the electrical signal, right? So we cannot have the operator look at the water level, right? So that has nothing to do with the electrical control system. So we have to find a way to convert the level signal into electrical, can be recognized, can be utilized in the system. So how do we do that? It's this corner over here, right? I know it's a little bit small, and later on you will see that the big picture of this device is called pressure transmitter. So basically we take the pressure level at the bottom of this reservoir, then we measure the pressure from that point, right? So on the real device, you can see here there's a port connect into the reservoir, and there's a clear pipe, small pipe, right? So those black pipes are the one, the piping, right, going to the water in and out, and going to the reservoir, right? So this white or clear tube over here is just like this line on here. We get the sample from the bottom of the reservoir, and then we go into the H port, high pressure port, to this LT, level transmitter. So because this particular device is called pressure transmitter, but we use for level measurement, so that's why we can call that level transmitter, right? So by using this transmitter, we can get the signal out from this device, either by the voltage signal or the current signal. All right, details I will show you later on. All right, so this is just a basic overview of this lab. Right, that's what we're gonna work with. All right, and I also am going to show you the video in a moment. All right, so that's let me finish the introduction on the devices. So on this slide, you see the real picture. All right, so that's the water level, and this is the control panel from the that unit, right? So that's that part, right? Speed control here, not included on here, right? So as you can see here, there's only a very simple terminal on the corner of here, which is here, this part, right? So this is what they call the control terminals of the variable speed drive. So remember, we talk about the motor control, right? So we talk about VFD a little bit, right? So that's similar things we have here. This is also a variable speed drive, right? So we can use the voltage or current as the control signal going to those terminals, right? So this pump itself, it has its own power supply. It's in this lab, in this trainer, we use the 110 AC power supply, and with this power supply, we can also use a low voltage signal to control the speed of the motor. So namely, for this particular trainer, we use from 0 to 5 volt. This is one type of control, or we can use 4 to 20 milliamp. So regarding of this part, I have to talk about more on the lecture. So these two type of signal can be used as the low voltage, low current signal to control the pump. So we can have the pump get more water out or less water, right? So that's basically how do we control the water level in the reservoir later on, right? So this is this part. Let's look at the next one. So this is the part going to the details with the variable speed control, right? So yeah, I should talk about that here. You can see here, right? Either 0 to 5 volt, or that's this one, right? If you use connect to this socket, or if you use the 4 to 20 milliamp, right? Same thing. So this is the one type of the controller we used on this. So let's basically, this one is here. It's this one, right? So we have the potentiometer or knob over here. You can turn around this to control the speed. All right. So regarding all this detail, you don't have to know a lot of that. You just right now you just use the this 5 volt going to this 5 volt, and that's it. So then you can use this knob over here to rotate, then to control the pump speed by using this. All right. So let's look at the next one. This one is at the top. Right? So this reservoir on top of here, you see here this part, right? So it has a device to check the water level, right? So that's the real picture on here. So you can imagine over here, if we don't have any device to monitor the high level, water potentially can go up to overflow, right? You don't want that happen. So that's why we have to use one particular type of flow switch, right? Remember, we have a flow switch on the motor trainer, right? So that motor trainer we have on here, over there is the normally open type. You can see the connector with that, or by that time I believe we use the symbol like this: two terminals, there's one switch, and then we have a float, right? That's the signal we represent normally open on here. Or you can use this, right? But this over here, you can see level switch. This one is normally closed. So that means when water level is low, somewhere around here, the switch is closed. But when the water level reaches to here, push the floater, right? You can see there's a float, right? Then when that water level push that over here, over high level, then the contact become open, right? But the type, we should call that is normally closed type. So what we use that for this type of flow switch, right? So we have to go back here. If you look at, so now I can explain this part on the diagram. So that's the LSH level switch, right? Check on here. When water level reach to here high enough, and this normally closed contact will become open. So we can use this switch connect into the power supply. So from here 0 to 5 volt, we can go through. I just draw like this, right? Normally closed contact, then connect to the pump, right? So normally we can use the 5 volt and adjust around here to change the speed. So once the water level reach to high level, and then this normally closed contact will become open, and then cut off the control power, right? The pump lose the control input, then the water level will drop, right? In this way, we protect. We don't want to have the water overflow on the reservoir, right? So that's this part. So now let's look at let me go back here. So remember this, we talk about the pressure transmitter as the level transmitter, right? So let's look at the detail of this transmitter. So basically, transmitter is just a term to represent the instrumentation or devices to convert the physical quantities into electrical signal. Right. More specifically, the output of this device, you can see here, either 0 to 5 volt or 4 to 20 milliamp. Right. These two type of electrical signal. Right. So on the slide, you can see here, normally with the pressure, we can use the pressure gauge. Right. But again, that's only an indicator, visible signal. Right. So the operator can read from the needle on here. But that has nothing to do with the control device. You can use this as the local device to monitor that, but you cannot use this type of signal into electrical control. So that's why we need to get the signal out from here, right? So so that's the picture from this device on here. That's the port to connect to the. You can see the high port. That's where we connect into the water. This clear pipe basically connect to here, right? Into here, right? So then the pressure go into this device, and with the calibration, we can get 0 to 5 volt or 4 to 20 milliamp. So what do we mean by calibration? So basically, we need to map a part of a range of pressure into those two output signals. Then how do we adjust that? Right? It's like almost like the signal amplifier. So we have to adjust both ends. We have two separate knobs, right? One is called 0, the other one is called span, right? So the 0 adjusts for the low level. So when you want to get the voltage, that's for the 0 volt. If you want to use the current as the output, that's the adjustment for the 4 milliamp. And the other, another adjustment on here called span. The span is the adjustment for the high level, right? Again, if you want to use voltage as the output signal, that's for the 5 volt. And if you want to have current as output, that's for the 20 milliamp, right? So that's the part of the lab. We need to do this calibration back and forth several times. All right. So in the video, I'll explain that. Because when we get the, I believe in the lab, we want to have the 10 centimeter on here. Yeah, at this level, so we want to map into 0 volt or 4 milliamp, and then on top, as I believe that's a 50 millimeter or something like that, we want to have the 5 volt or 20 milliamp output. So how do we do that? So we need to make the water level on the low level and high level several times. When we reach to low level, we adjust 0 to try to get a 0 volt or 4 milliamp, and then we need to get the high level to adjust the span, then to get the 5 volt or 20 milliamp. But remember, these two are interconnected with the device internal circuit. So whenever you adjust span, the 0 will be compromised. So you have to come back to the low level to adjust the 0 again. So once you adjust 0, make it perfect, then the span may be changed to different settings. So then you have to go back to the high level to do that again. So in this way, every time when you do every time adjustment calibration, you make both ends more accurate to the target you want. Right. So that is what we need to do with this lab. All right. So now I can start to play the video on here. You can start to look at it on here. All right. So all right, before I go in, all right, so I can explain a little bit. All right, so you can see here, this is the clear tube, right? So we get from the bottom, then connect to here, right, the high port, and that's the transmitter. And then currently I insert the red probe into 0 to 5 volt, right? So that's the voltage signal I'm trying to get. All right, so then I have a DMM, right? This DMM will show the voltage output from this transmitter, right? With this output, we can connect into other circuits later on, right? So right now you can see that shows 0.07 volt, almost 0, right? So in order to make this video shorter, we already set up this transmitter being calibrated. It's very close to the target we want. All right, in the real lab, you probably will spend some time to back and forth to adjust these two knobs several times in order to get the output more accurate, right? So as you can see here, so I zoom in here. This is the transmitter. This is the DMM, right? So you can see here right now. That's adjust for the pump. With the pump turned on, you can see the water level reads high. It's going to up. You can see same thing for the output, right? So before was 0.07, reach to really high, right? It's almost 5 volt. Like I said, in order to make this video shorter, we already start the calibration of this transmitter, right? So that's why you see right now it's almost to the top, right? I believe it's 51 or something like that. We want to get 5 volt. You will see that. And let's look at here. Continue on here. So I'm trying to get on here. All right. So yeah, you can see here right now it's 53 centimeter, right? It's almost overflowed on here, right? I have some tube on here in case of the water overflow, but you you shouldn't get this high. You can see here that's we talk about the flow switch, right? This part is the flow. In the lab, you can try to raise the water level to here, and you will see the pump being cut out on the control. Right? So that's why the LSH is being used to control of the high level. Right? Let me finish out here. So that's the two wires. You can see here the two wires come out from the top, right, into the control circuit. So right now you can see 5 volt, right, almost here. Again, we already did some calibration. So over here is just doing some minor adjustment. Right. So in order to have the level. Okay, so you can see if we have the water drop, right? Yeah, you can see the voltage dropping, right? Because the water level is dropping, right? So the purpose of this lab is that we want to convert this physical quantity, right? So you can see here the water level in different heights, different level, right, into electrical signal. With electrical signal from lab 1 to lab 10, we use the we call discrete or logic or digital input output, right? It's only 0 or 1 or low voltage, high voltage. We don't care the middle voltage, middle reading. All right, so any voltage in the middle, right? So, but for this lab, it's different. Lab 11, we start to look at here, right? So this DMM right now shows 3.21. So that mapped into pretty much the current voltage, the water level on here. That's the target we want to get, right? So as a result of the lab, we want to have the 10 centimeter around here mapped into 0 volt. And one common mistake is that you see the water level drop, but even before drop to 10 centimeter around here, around 15 or 17 centimeter, you already see the voltage change to 0 volt. That's not right. You should start to turn rotate the zero span to make it the output more accurate, right? So so that's basically the process of calibration. You cannot only just look at either end. You have to take care of the trend, right? Because at the end of the lab, I need you to show me in the water, if the water level right now is drop in the middle of the range, we should get 2.5 volt. Right, so that basically we get almost a linear output, right? Let's look at the right. You can see here, yeah, it's going to 2.5, right? So over here it's almost halfway on the level, right? I should show you on that part, but in order to make a video shorter, I have to skip that part. But over here you can see on the 10 centimeter around over here, we get reading 0.02, right? And one common mistake I see in the lab is that some students forget to take care of the trend. Like I said, if the level is it's like a 15 centimeter, but you already get it very low at 0 volt, that's not right. You should start to adjust the zero earlier, right? So that's what you need to